Okay, so from yesterday, I don't think this will take too long. You should get a little time to work maybe. Okay, so you guys review for me. What are the important things we said yesterday? Sum it up.
Infinity. Something about the degree of the ratio of the leading coefficients. Let me look at
True. True.
There can be two horizontal asymptotes.
Could be, right? We looked at one case where there were two different horizontal asymptotes, one left and one right. That can happen.
If the degree of the numerator is exactly one more than the degree of the denominator, then it's linear.
Good. Okay, if the rational function has a numerator whose degree is one greater than the denominator, then you know that the asymptote is going to be linear. It's going to be a slant asymptote or an oblique. Sometimes they call it an oblique asymptote. Same thing. We know that slant asymptotes and horizontal asymptotes would be things we would find at infinity. So we'll take limits as x approaches positive or negative infinity. Vertical asymptotes would occur where? At a value of x where would you get a vertical asymptote? Where what equals 0 and what doesn't equal 0? Denominator does, numerator does not. Good. All right, we're getting it. So what I want to look at today is this is going to be kind of a review of just some algebra that supports this calculus. So let's analyze this function. Okay, what's the domain of this function? Yeah, all values of x except negative 18. What's happening at negative 18? There's a vertical asymptote because 18 is a unique 0 of the denominator, right? Okay. So, yeah.
I don't know if it's a vertical asymptote or a hole.
Because if 18 is a 0 of the denominator but not the numerator, that's a vertical asymptote, guaranteed.
If it's a 0 of both, then it's a hole.
Well, if both are 0, then you have to resolve the indeterminacy. Yeah. Yeah, you can just see it's not. I mean, you can see that 18 is not a factor. We could factor the top, right? The top factors into x minus 17 times x plus 1. And so negative 18 is not a factor of the top. But you could also just plug it in. You can see it's not going to give you a 0 on the top. So the domain, x is not negative 18. We get a vertical asymptote at x equals negative 18. And now you tell me, is it going to have a horizontal or a slant asymptote or neither? Slant. How would we find the equation of the slant asymptote here? Synthetic division. We simplify the quotient with synthetic division. And what goes out front? What goes top row? Remainder box. Okay. And what do we get? Something. Okay, so it doesn't really matter. We're just going to get this whole thing is equal to x minus 34 plus some number divided by x plus 18, right? But in the limit that x approaches infinity, the limit of f of x as x approaches plus or minus infinity then is going to equal the limit of x minus 34 plus some number divided by x plus 18. And we know that that's going to shrink to 0, right? So our slant asymptote then is right there. We get a slant asymptote at y equals x minus 34. And we got it. Okay, make sense? Okay, so what about one like that? What's the domain? What is it? It's all reals, yeah. How come? Denominator has no zeros, no real zeros. Okay, so it's all reals. Do we get vertical asymptotes? Can't, because there's no zero of the denominator, right? Are we going to get horizontal or slant asymptote? Okay, how are we going to find it? Long division. So probably we want to review that a little bit, right? Okay, so let's do a little long division. So we're going to divide. What goes inside? Top. Okay, how am I going to write that? X to the 7th plus 2x to the 6th plus what? 0x to the 5th, right? Remember our rules for long division. You have to preserve a column for every power of x. You have to include zero coefficients. So we're going to get plus 0x to the 5th plus 0x to the 4th plus 0x cubed plus x squared plus 0x plus 2. What goes out front? X to the 6th plus 1. Okay, and how do we play this game? Yeah, we're gonna simplify the quotient of the leading terms, right? So essentially, we're just asking leading term inside divided by leading term outside, which means leading term on top divided by leading term on bottom, right? So that gives us, if we do that, what? We get x to the 7th over x to the 6th gives us x, right? And I guess technically I probably should put that clear over there. Doesn't really matter. But we'll put it in the x column. How about? So what do I do with that x? Good. Going to multiply by what's the denominator, what's outside. So if I distribute that, I'm going to get x to the 7th plus x, right? And then what do? I subtract. And remember how I taught you to do this. You're going to put a negative outside, put it all in parentheses, and then you just subtract vertically, right? So those guys cancel. This gives me 2x to the 6th. I get my 0 x to the 5th plus 0 x to the 4th plus 0x cubed plus x squared. 0x minus x is negative x plus 2. Okay, now what? Okay, what do I get? 2. Leading term inside divided by leading term outside is 2. Distribute the 2, and we get what? If I distribute the 2, we're going to get 2x to the 6th, and then I'm just going to get plus 2. And I'm going to subtract the whole thing. And that's going to be my remainder, isn't it? Anything I'm left with. Okay? So that gives me x squared minus x, and those guys cancel. So that's my remainder. So then this whole thing, f of x, is really just equal to equals what? X plus 2 plus x squared minus x over my denominator, x to the 6th plus 1. So in the limit that x goes to infinity, what's going to happen to the remainder term? It's going to go to 0 because it's a rational function where the denominator has a higher power of x. It has to be that way, right? So this tells me then that my slant asymptote, I get a slant asymptote at y equals, what was it, x plus 2? Everybody good? Make sense? Okay. Well, I'm going to probably turn you loose here. Is there any reason to do this one? I mean, probably not really. I mean, this is just like the last one. There's really, yeah, I don't see any reason for you guys to, we don't need to do this. We just did one like it. I'll stop. You guys can work on the assignment, get questions answered. This is it, right? So I'll put up review assignments, a review assignment, and you can start prepping for our test too.
Friday test?
We can probably put it off to Friday, I think.
Yes.
We'll see. No.
We should do it on my birthday. My birthday